it's important to recognize that when we subtract coordinates, we get distance or displacements between the positions. So when we subtract x coordinates, we get horizontal displacement or horizontal change. And when we subtract y coordinates, we get vertical distance or vertical displacement, which is vertical change. And what we're looking for in slope is the changes in x compared to the changes in y, or actually in the order we want to do it, we want to do y first, the changes in y divided by the changes in run. So this is our definition of slope. It's a ratio of rise to run. And as we change the ratio of rise to run, okay, so if I have my rise and run here, as I change the ratio of that rise and run, what will end up happening is I will change the angle of that line. So if I take that, and if I shorten the run, I get a steeper slope. So if my denominator gets smaller, my rise over run ratio gets bigger. If I make my run bigger, my slope is smaller. Okay, so if I make the denominator bigger, I get a smaller slope. Okay, so if I do the same thing with my vertical, if I change the rise, okay, if I make the numerator smaller, I get a smaller slope. If I make the numerator or my rise bigger, I get a bigger angle or a bigger slope. Okay, so as I change that ratio, either the horizontal or the vertical component of that, I will change the angle of that line. And this slope is really important to us because it gives us an idea of how fast the linear function is changing, okay, or increasing or decreasing. And it gives us the angle of this line, which then tells us the shape of this relationship. And again, we want to know what this relationship looks like. So to calculate slope, we need to get the change in the y and compare that to the change in the run, or the change in the x. Okay? So we want to find the changes. So to find the changes in y and changes in x, we need to break it down into our vertical and horizontal components. So what I'm going to do, and it doesn't really matter if I use a big triangle or a little triangle, but we need to get a horizontal and vertical component to this line. And then we can deal with these horizontal and vertical components independently. We can separate the y's from the x's. So here I've drawn my slope triangle. That little triangle is a slope triangle. I could have drawn a smaller triangle and the ratio of the sides still remains the same. So what I want then is, using this slope triangle, I want to find the vertical component of this slope, or the change in y. To find the change in y, I'm going to subtract the y positions. Okay, in this case, I can just count. Okay, so it looks like it's 1, 2, 3, 4, 5. But to get the change in the y using my subtraction, I'm going to end with y equals 5. I'm going to start at y equals 0. Okay, so I've gone up. So it's my change in y is positive 5. And I can do the same thing for my x's. I want to find the change in the x's. So I'm going to end at 0. And I started at negative 6. Okay, so if I subtract those two positions, I get the change in x. And if I count it 1, 2, 3, 4, 5, 6, I should end up with positive 6, which I do. So there's my rise and run components. Now to then calculate slope, I need to put those together. So slope value then is going to be the change in y, okay, which in this case is positive 5, divided by the change in the run, or the change in the x. The change in the x, in this case, is going to be plus 6. So we went right 6, up 5, So my slope ratio is 5 over 6. Okay, so then I'll just write that as positive 5 over 6. So it's going up at a rate of 5 up, 6 across. Okay, so there's my slope. And although I've drawn my slope from left to right, we could easily have done it right to left. We could have pointed our line, our arrow this way. Okay, it doesn't really matter that both directions represent the same slope. So as long as we have our y1 and y2 and x1 and x2 in the same orientation, we'll get the correct slope. We might be measuring it in this direction, we might be measuring it in this direction, but as long as we're consistent, we'll get the correct slope. The sign will be correct. It's going up this way or down this way. So given any 2 points on the line, okay, we have x1, x2, x1, y1, and x2, y2. Okay, so in this case here, the way I've drawn this, this is our x1. This coordinate was our x2. This coordinate has y1, and this coordinate would have y2. And so we end up with the end position as the x2 and y2 positions. So we do n minus start for both the change in y and change in x. And that gives us our slope ratio of plus 5 over 6. Okay, so we generalize then our slope formula. Okay, first of all, make sure you understand that it is really just measuring change in y over change in x. And then we end up with our slope formula that looks like this. Okay, and in this case, we measured our slope in this direction. But like I said, if we switch these around, as long as we switch around the bottom, we can measure slope in either direction.